Okay, now let's start section two and video two, and we're going to talk a little bit about short run production. And remember, short run production is we had our two inputs, right? We had labor and capital, and we said that only one can be varied. So that means that we are going to fix or hold constant one of these other variables. And so let's consider this short run production function. Holding capital constant, our production function then becomes a function of labor and fixed capital. So remember, this is labor, this is capital, this is our maximum output, and this bar above the K, right? This bar just means fixed or constant. It's not another variable. It's nothing like that. It's not a different variable. It just means that K is going to take some value and it's always going to be that value. That value is not going to change. So this is also called the total product of labor, which means that we can derive two um, different things. Oops, this is an incorrect definition. This should be the average. This is all wrong. Um, this should be something like this. So just pick this one up here. The short run production function, right? So we're holding something constant, right? We can derive two things from the total product of labor. So we can get the marginal product of labor, which says if we were to hire one more person or work one more hour, what is the extra unit of output that we would get from that, right? So if we're already working 20 hours a week, we're making 100 coffees, so we're making 5 coffees an hour. If we worked one more hour, would we be in like more of a flow state, and so we would get like 2 coffees or however long, whatever. If it was constant, then we would probably get another 5 coffees. The marginal product of labor, and again, every time that you see marginal in front of this, you should be thinking it like it is the additional dependent variable following from a 1 unit increase in the independent variable. And then we have this other idea called the average product of labor, which is just your total output divided by your number of labor hours, the ratio of output to the amount of labor employed. So when we're thinking about this and thinking back to our original questions and our original consumer framework, a lot of these we've been using analogous things, right? So the marginal product of labor could also be thinking like the marginal utility stemming from one good or the other. Why do we never have to think about the average utility? Well, the average utility doesn't matter. I mean, like the utility varies over time. It was my point. Is that there would be an average utility from the good, but it's not set on a spectrum, so it doesn't really make sense to interpret it that way. So why do we now have to worry about average product of labor? Because we have to think about paying every worker the same wage. And so we have to take our output that we're getting and we have to like divvy up all of those returns to our same person. And so that's another instance. In our utility, we're only thinking about one individual. So the average is just me. Whereas in the firm, we have to think about employing a lot of different individuals. And so we have to consider all heterogeneity in individuals, whatever. But let's look at a quick example here. So let's look at this is our production function. So what is the short run production function if capital is fixed at 10? So what if K bar equals 10? Well, then our Q is going to look, oops, 3L squared minus 0.1 L cubed, or L plus 30L squared minus L cubed. This would be our short run production function. So now, given our formula for the marginal product of labor, let's find its average and its marginal product of labor. So our MPL, if we recall, is the partial of F with respect to L. And so this would be 1 plus 60L minus 3L squared would be our marginal product of labor. Our average product of labor is going to be Q over L. And that average is always going to be the same. And so, if we wanted to draw these, oh, this is not going to go well. If we put labor here and output here, no, we wouldn't put output here. Um, oh, we're gonna want two figures, sorry. In this one, we're gonna want output and labor. And this, and then in the bottom, I actually think this will just be a lot easier if we just look at the textbook example. Because I'm not going to get those curves correct. But this is our same example, just a little bit more pointed. So if we notice here, this is our total output, right? So this would be our production function. Right? It's got some funky curves. And on here, this was our MPL and APL. And there are a couple things to notice on this, right? So first, where is the marginal product of labor equal to 0? It is going to be right here at C at 20 ounces, 20 labor. And this is important because when the marginal product of labor is equal to 0, notice in our production function, this is when our production peaks, right? So this is when we are maximizing our production. So we're maximizing output when MPL equals 0. What about when they cross? Well, when they cross, so at B, right, when they're equal to each other, this is when we have constant returns, right? So if we notice here, there's this line of constant returns, and B is tangent to that. So when MPL is equal to APL, we have constant returns. And so what's the relationship between MPL and APL? I mean, I think it's pretty obvious. They help us dictate a lot of what happens in the production function, and they dictate the entire, um, almost everything. And so there's going to be a lot of this thing here, right? So if we come back, total product of labor shows output rises until L equals 20, right? So we saw that this output rose until L equals 20. Um, the next thing that we have is that APL and the MPL both rise initially. So this rises initially, this also rises initially. Initially, the marginal product of labor would rise due to specialization, but adding more workers makes all workers more productive, right? That makes sense. If we are think about mowing lawns, if we're adding more people to mow lawns, we're going to be able to mow it faster. But because we have a fixed product of capital, our marginal product of labor does begin to decline when people start getting in the way of each other, right? The lawn is only so big, and if everybody is running their lawnmower, we're just going to start running into people. And so we might be better off just having three people instead of 10. So, what happens with the math, right? When we have our marginal product of labor being above our average product of labor, we're going to see that our average product of labor increases, right? So if marginal product of labor is higher, average is going to increase. As soon as the marginal product of labor becomes less than the average product of labor, we see the average product of labor start to decline. When these are intersecting, APL is maximized. But when the MPL is less than zero, that is when our production starts to decline. Right? And so those are the big takeaways here. They're all listed right here. This is what we should remember with the math. Um, Other than that, I think that we're pretty solid. So let's do an example. So suppose we were given the following production function, right? We have Q is equal to L to the 0 0.5, K to the 0 0.5. What is the MPL? I mean the APL. Well, if we remember, the APL was Q over L, and we know that Q is this over L, and so we have K bar over L all to the 0 0.5. And what about the MPL? Well, the MPL was this partial with respect to labor. And so we are going to get 0 0.5 L to the minus 0 0.5 K bar to the 0 0.5. Or 0 0.5 K bar 0 0.5 over L to the 0 0.5. And lastly, or I guess there's another way that we could write this, is if we multiply top and bottom by L to the 0 0.5, it could also just be 0 0.5 times Q over L, but I think I would prefer you guys to write this answer. I know that this is probably easier to interpret, but it's going to be easier to make sure that we're not making mistakes in the math. So then what would be K bar was equal to 64? Our APL would be square root of 64 is 8. And our MPL should be 4. I guess we'll move this down here. Those are the type of style of questions that you're going to have to know for the short run production process. So if you can understand that and you can follow that, then I would absolutely just keep doing that. And so now we've got the law of diminishing marginal returns. And so this is very, very similar to our decreasing marginal utility. So if a firm keeps increasing our input, holding all others constant, the corresponding increases will be smaller and smaller. So if we come back up here, imagine that we were doing these small increases just from here. These are going to get smaller and smaller and smaller until they drop, right? And so this means that the second partial derivative is less than zero. And this is also called the diminishing marginal product if you see that somewhere, but for the most part, you'll see it as just the law of diminishing marginal returns. And so we've got one last example for this section. Suppose that we were given this following production function. So let's find the MPL. Again, then we are going to get partial of f, partial of L, and we are going to get 6k bar plus 6L minus L squared. When is MPL equal to 0 or profit maximized? Output, not profit, sorry. Well, we set this equal to 0. Solve for L. I don't want to. You guys would be more than welcome to use a calculator to do something like this. Um, if we throw this into an algorithm machine, we're going to get that L is equal to 3 minus the square root of 6k bar plus 9 or something like that. Um, what other questions could we ask? So when is the MPL decreasing? Right, well, that is when we want to find L when our second partial is less than 0. So let's take the derivative of our MPL again. And this is going to be 6 minus 2L. When is that less than 0? Well, that is going to be when L is greater than 3. Right, so those are all questions that you could be asked on the homework or on the exam to do. For the most part, I think that this is pretty straightforward, especially short run inputs because we're holding one thing constant. Um, but yeah, for the most part, should be pretty straightforward, should be pretty easy. If you have any questions though, please let me know. Cool. That's going to make the end of video 2. I will catch you guys for video 3.